Let's take a look at question number 52. In 52, we're asked to graph this function and also give some information about its domain and range. The first thing we would want to kind of take a look at here is how this graph is going to open, whether it opens up or down, and that's determined by the coefficient a. This quadratic function is presented in vertex form, so we can look at it and see that the value for a, which is the number outside this parenthesis, is -1, which is less than 0, and that tells us that it's going to open down. So whenever a is less than 0, the parabola opens down. The next thing we can talk about is the vertex. If it's in vertex form, then you can just visually look at it and tell what the coordinates for the vertex will be. It's the opposite of the number in the parenthesis with the x, will be the x coordinate of your vertex. So if I see a +1, then it's going to be a -1 that goes here. And then the y value of the vertex is literally the same number you see on the outside. So that would be 4. That gives us our vertex. If you wanted the equation for the axis of symmetry, even though they don't ask for it, it's always x equals the x value of your vertex. A couple other points we would like to have would be the x-intercept and y-intercept. To find the x-intercept, you set f of x equal to 0 and solve for x. This would say that the negative of x plus 1 squared plus 4 equals 0. We have a perfect square quantity, so we can use the square root method to solve this. I'm going to get the square quantity by itself. I subtract 4 from both sides. I divide by -1. This would give us x plus 1 squared equals +4. Take the square root of both sides. That would give us the x plus 1 equals plus or minus the square root of 4, which is 2. So we have x plus 1 equals -2. X plus 1 equals +2. Let me zoom in. Subtract 1 from both sides, you get x equals -3. So -3, 0 will be 1 x-intercept. Subtract 1, subtract 1. The x equals +1 will be our other x-intercept. To find the y-intercept, this is a little bit easier, just an evaluation. You evaluate f of 0. If I plug 0 into that function, f of 0 is going to be the negative of 0 plus 1 squared plus 4. That will ultimately end up giving us -1 plus 4, which should be equal to +3. So the y-intercept is going to be 0, 3. That should be enough information to go ahead and graph this thing. So I begin by plotting my points. The vertex is at -1, 4. So I go 1 to the left and then up 1, 2, 3, 4. That would be right here. We know that the y-intercept was 0, 3. So it intercepts the y-axis here. We had our two x-intercepts. They were -3 and +1. -3 is here. +1 is there. And if it helps, you can draw that vertical line through the vertex. This was our axis of symmetry. And just try to make sure that it looks symmetric as you draw it on either side of that line. And as the data points indicate, and we saw earlier, this is going to be a parabola that opens down. Okay, so this would be the graph of our function. They also asked us for the domain. The domain of any polynomial or any quadratic is always -infinity to +infinity. This graph extends infinitely far to the left and infinitely far to the right on the x-axis. For the range, because it opens down, there will be a maximum height. It's going to extend all the way down towards -infinity, but it's going to reach a maximum height given by the y value of the vertex, which was at 4. So we have a domain of all real numbers and a range of -infinity to 4. In 53, they want us to determine whether the function has a max or min and then to find it. First thing we want to do is figure out how this thing opens. Here, the value for a is equal to 1 which is positive, which means that this thing is going to open up. Whenever a parabola opens up, the vertex turns out to be a minimum value. So this quadratic would have a min value. To find the minimum value, we're going to use the vertex formula. This is an absolutely essential formula you have to know for the final. The coordinates of the vertex are going to be given by negative b over 2a, and then the y coordinate is just f of negative b over 2a. In this case, a is 1, b is negative 2, and c is negative 9. So the x value is negative b over 2a, which would be the negative of negative 2 divided by 2 times 1, which would be 2 over 2, which is 1. So the x value of the vertex is 1, and then all you have to do is plug that number into the function to find the y value. This would be 1 squared minus 2 times 1 minus 9, which is 1 minus 2 minus 9, which would be negative 10. The actual minimum value itself is going to be the y value. So we would say that this function has a minimum of negative 10, and then the actual location of it is the x coordinate. So it's at x equals to 1. So our function has a minimum of negative 10, which occurs when x equals positive 1. In 54, they're asking for the same type of information. Let's look at this quadratic here. Does it have a max or a min? And then find the said max or min value. Here, the coefficient of the x squared is negative 1, which is less than 0. So this one's going to open down. Anytime a parabola opens down, the vertex is going to be a maximum. To find the maximum, we are going to, again, use the vertex formula. A is negative 1, B is 2, C is negative 8. The x value of the vertex is negative b over 2a, which is the negative of 2 divided by 2 times negative 1, which is negative 2 over negative 2, which is 1. The y value is going to be found by doing f of 1, which is the negative of 1 squared plus 2 times 1 minus 8. That's going to be minus 1 plus 2 minus 8, which should be negative 7. So the vertex is found at negative 1 comma negative 7. This is our maximum, so it has a max of negative 7, and this occurs when x equals 1.